Hello students, here I Pooja Garg welcome you all in my online mathematics classes for class 9th. Due to coronavirus, we have to stay home, stay safe. We planned to provide online classes through YouTube channel. So before starting any topic, I request you all to make notes if possible to maintain a thick register. So today I am going to start chapter 1 number system. So under this chapter we are going to discuss two topics, rational number and irrational numbers. Second topic is real numbers and their decimal expansion. So let us start with the basic concepts. Here you can observe a flow chart, and this whole flow chart we can call it as real number system. Now very first I'll take the natural number. You know what are natural number? Yes, these are the counting numbers. Counting numbers means it starts from 1, 2, 3 up to infinity, and the set of natural number will represent by alphabet n. And if we include 0 in the natural number, we'll get a set of whole numbers which is represented by letter W. And if I'll include here in all the negative numbers, means the numbers which is towards the left side of a number line, then it becomes a set of integers, and here it is denoted by letter I or Z. Now here if we include some fraction numbers, fraction means a part of whole, and fractions also we have different types, then it becomes a set of rational numbers. And if we include some irrational numbers, means which cannot be expressed in P by Q form, this whole system becomes a real number system. So I'll brief you out about the rational number. What are rational number? So let us see a rational number which can be expressed in the form of P by Q, where P and Q are integers and co-primes, and Q is not equals to 0, is said to be a rational number. And here we have some examples. These are all the examples of rational number. You can observe this 0.5. 0.5 can be right 5 by 10. Yes, as it is in the form of P by Q, where Q is not equals to 0. That is why these type of numbers are also known as rational number. And the now next one is irrational number. So here irrational numbers are nothing but the number which we cannot express in the form of P by Q, and P and Q are integers and Q is not equals to 0 is called irrational numbers. And here we have some examples. You can see root 2, as you already did in earlier class, how to find the value of root 2. It never ends. You can observe 1.4, 1, 2, 1, 3, 5, 6, 2, 3, 7 and so on. It never ends. Means here we cannot express these kind of numbers in P by Q form. Now the next one is real numbers. Actual, what are the real numbers? Real numbers means the collection of all rational and irrational numbers is called a collection of real number, and here real number will express with the letter capital R. Now there are some note points that you have to note it down. Every whole number, natural number, integers are rational number, but every rational number is not an integer, natural number or a whole number. And we know that there are infinitely many rational numbers between two rational numbers. Similarly, we have infinitely many irrational numbers between two irrational numbers. So here, I hope you understand all the basic concept based on the real, rational and the irrational number. So now I'm going to discuss some questions based on this topic. So very first concept is how to find the rational number between two given rational numbers. So here I took some questions. So please look and try to understand. So here the very first question is find two rational number between 1 and 2. So for solving this question, we have two different ways. So the very first method is by mean method. Mean method means we are finding the mean between the two numbers, and you know how to find the mean. We'll add the numbers and divide by 2. So yes, here is a very first step to find the mean. Like suppose A and B are two rational numbers, then how to find the very first rational number? A plus B by 2, suppose it is equals to C. Now suppose I want to find the second rational number, then you can take A and C. Now A plus C divided by 2, which says D, and so on. In this way we can find infinite many numbers, but this method seems to be little bit lengthy. Suppose we need to find 10 rational numbers, 20 rational numbers or 100 rational numbers, so it will take too much time. So Here first you see an example how to solve by using this method. Suppose I need to find two rational numbers between 1 and 2. So here you can observe 1 plus 2 divided by 2 is equals to 3 by 4. Now if I want to find second rational number, then I can take 1 and 3 by 2. Sum of these two numbers and divide it by 2. So I'll get 5 by 4. Hence 5 by 4 and 3 by 2 are two rational numbers between 1 and 2. Now I'm going to discuss alternative method how to find rational numbers between two given rational numbers. So very first step, make their denominators same. If they are same, then very good. Otherwise you have to make the denominator same, that you know how to make them same. Second step, as we need to find two rational numbers, right? So here what we'll do, if we want to suppose find two rational numbers, so we will add 1 in it. Means 2 plus 1, 3. So multiply and divide both the numbers by 3. Suppose I want to find 5 rational number, then which number I'll take? 5 plus 1, that is 6, right? So here if you will see the step, I have multiplied here, multiply and divide both the numbers by 3 and 3. So what will get? 3 by 3 and 6 by 3. Here you can see denominator is same. So these two numbers 4 by 3 and 5 by 3 lies between these two numbers. So hence 4 by 3 and 5 by 3 are two rational numbers between 1 and 2. I hope you understand this. Now there are some questions based on this which you can do. You can try to do exercise number 1.1 from your textbook, and here there are some more questions which you can try. And I request you to write it down, all these questions. Now I'm going to start the next topic, that is real number and their decimal expansions. So again we'll see with the flow chart. So look over here. Now you can observe decimal expansion of a real number. There are two types, that is terminating decimal expansion and non-terminating decimal expansion. Terminating, here you can see I have written here rational. I'll explain you later why it is a rational number. And under non-terminating decimal expansion, here we have two different types, that is recurring. Recurring means repeating decimal expansion. Non-recurring decimal means non-repeating. So here again I have written rational and here I have written irrational. So I'll explain you why they are rational or irrational. So first I am going to describe you about terminating decimal expansion. Terminating means what? Ends. Means it ends. The decimal expansion terminates after a finite number of steps. That is, after few steps, remainder becomes 0. Here you can see some examples. 1 by 4 when we divide will get 0.25. Similarly 5 by 6 by 5 which is equals to 1.2, and in both the cases we are getting remainder as 0. Now the next is non-terminating decimal expansion. The decimal expansion which never terminates. Never terminates means never ends. In this case, we do not get remainder as 0 after any stage. Now the next one is non-terminating recurring decimals. Under this, remainder repeats after a finite steps, means here the repetition of block of digits in a quotient occurs. For example, you can see 1 upon 3 when I'll divide. So what do I get? Again and again I am getting remainder as 1. So here the quotient part is 0.333 and so on. It never ends. So here we can rewrite it as 0.3 bar. Bar means with the number or a block of digits which repeats again and again. Now the second one is non-terminating, non-recurring decimal expansion. A decimal expansion that continues endlessly with no group of digits repeated endlessly. Decimal of these types cannot be represented as fraction. These numbers can be easily created by using a pattern. You can follow up these examples. Here we have one example, 1.14114, 4 times 4. Then here what you are observing, do you get any fixed pattern? or a block of digits which are repeating? No. Here 1, 4, then 2 times 1, then 4, then 3 times 1, then 4, then 4 times 1, then 4, and so on. And you can see in another example as well. So these type of numbers basically we cannot convert in P by Q form, and here hence these numbers are known as irrational numbers. So there are some note points which you have to remember. So very first is decimal expansion of a rational number is either terminating or non-terminating recurring. Second point, decimal expansion of irrational number is non-terminating, non-recurring. Third, the decimal expansion of all the rational numbers whose denominator of the form 2 power p, 5 power q, where p and q are whole numbers, always terminates. Means here this third point we can use without calculations, means without showing long division we can find it out whether the particular number is terminating or non-terminating. Now I am going to discuss very important question based on this topic. Here you can see the example. Express 0.6 bar in the form of p by q, where p and q are integers and q is not equals to 0. So here I'm going to show you here by step. The very first step, let it be as x. X is equals to 0.6 bar. Take this equation as 1. As here only one digit is repeats. So what we'll do? We'll multiply both sides by 10. So what we'll get here? 10x is equals to 10 into 0.6666. Here, if I'll multiply these two numbers, so we can shift one decimal towards our right. So what we'll get? 6.666, or I can write it as 6.6 bar. Now what? Give this equation as 2. Now what is the next step? Third step is we are going to subtract equation number 1 from equation number 2. So what do we get? 10x minus x, which is equals to 9x. 6.6 bar minus 0.6 bar is equals to 6. It means x is equals to 6 by 9, which is equals to 2 by 3. So it means we can represent 0.6 bar as 2 by 3. Hope you understand this example. Now, second example. Now you can observe here. Is there any difference between the first and the second example? Yes. Here you can observe. Here I took a number 0.7 and bar is only on 3, 4, 5. So here what we'll do, the very first step, as there is only one digit which is after decimal, which is without bar. So very first step, we are going to multiply both the sides by 10. Suppose there are two digits without bar, then what we'll do? We'll multiply both the sides by 100. So let us take this equation now as first. Now on how many digits we have a bar? 3. So now what we are going to do? Multiply both sides by 1000. So what do we get? Here we get 10,000. And here we'll get this. Now again subtract 1 from 2 equation, we'll get this. After solving, we'll get it as this one. Now again here we have some assignment based on this topic. Again first you try to do exercise number 1.3 from your textbook and do these questions. Please note it down so that you can try these questions. So today's our topic we have completed. So don't forget to like and subscribe my YouTube channel. Thank you.